All right, so let's just review what motion looks like on a dot diagram. So imagine that you have two cars, a red car and a blue car, and they are both traveling at 5 meters per second. Okay, they're both traveling at 5 meters per second. And as they travel, every second they're going to drop a drop of oil. So if we were to look at that, we would see that after the first second, they both drop 5, 10, 15, 20, 25, 30, and so forth. So what they're doing is since they both have the same constant speed, by definition, they're going the same distance every instant in time. So as we look at that, every second they drop the same amount of, they go the same distance every instant in time. So um, after 2 seconds, they've gone 10 meters, and then after another 2 seconds, they've gone another 20, another 10, which is at 20, and so forth. So what would happen if one of them is traveling faster? So let's put one at 10 meters per second. Well, the red car is going to travel 10 meters every second. So after 2 seconds, it should be going 20 meters, whereas the blue car would have only gone 10 meters. And there we go. So notice the slower car, the dots are equally spaced, indicating constant speed. And they are closer because it's not going not going as far every instant, only 5 meters every second. And for the red car, which is traveling at 10 meters every second, the dots are constantly evenly spaced, and every second it goes 10 meters. So after 2 seconds, it's gone 20 meters per second. All right, so let's talk about what would happen if now they are accelerating from rest. So let's just have one travel at 5 meters per second, okay? The other one is going to have a speed up of 2 meters per second every second. So the red car is going to travel at a constant 5 meters per second every second, but the blue car is going to speed up by 2 meters per second every second. So at first he only goes 2 meters, then he goes 4 more meters, then he goes 9 more meters, and so forth. So he keeps going further and further and further because he gets going faster and faster. Remember, the faster an object travels, the further apart the dots are. So if you're increasing your speed, the dots are going to get further apart. So the direction of acceleration of getting faster here is to the right. What if I said the direction of acceleration was to the left? So in order for this thing to get faster and faster and faster, it would have to be moving to the left. But in fact, it's going to start out at 10 meters per second, and it's going to slow down by 2 meters per second every second. So we'll just compare the red car traveling at a constant meters per second to the blue car that starts out at 10 meters per second and slows down by negative 2 meters per second every second. So first it goes 10, every instant in time, actually turns around here. So every instant in time, it slows down. Notice that the direction that it would be speeding up is in the negative direction. So if it was moving to the left, it would be getting faster and faster, but it's not. It's moving to the right. So the result is that it slows down, and I can see that because the dots are getting closer and closer. So the rules of thumb are, if the dots are equally spaced, it's constant speed. If the dots get bigger to the right, it's accelerating or would get faster to the right only if it is already moving to the right. If the dots get further to the left, then that's the direction that it wants to speed up in. And so if it's trying to go to the right, but acceleration is to the left in the negative direction, the result be that it slows down, and you can see that because the dots get closer and closer.